All right. Welcome, everyone. Thank you for being with me today in lunchtime. So happy to see that it's a full room, and welcome to this session where we will explore how calculations can help you analyze data even further today. So this event is live streamed, so I would like to say hello to and good evening to people who are watching from Europe, and hopefully nobody is watching from Asia, but if anybody is, very early good morning to them as well. So my name is Selçuk, and well, I don't know how to pronounce it so that people can get it from the first time, but it's just pronounced as it is written. So just if you come to me, just say Selçuk, and yeah, that's it. But I come from our London office, so I've been working for Tableau for 4 years so far. But as you can see from the accent, I'm not actually native to London. So some of you may think from the name that maybe I'm coming from Turkey because it's a Turkish name. But actually, I'm coming from a tiny country in Europe called Bulgaria. And I live, and my hometown is a really, well, it didn't work actually. But it's a really small town in South Bulgaria called Momchilgrad. Oh, just a second. How can I play this? Here you go. And probably you can fill in this room with 1/3 of the population of the town. So it's really tiny. But 4 years ago, this week, I actually moved to London to work for Tableau. So this is my 4th year anniversary in Tableau. So it's a special week for me. And I actually remember this week 4 years ago because I was sending pictures of my brand new US visa to HR. So 4 years later, I'm here. Well, when I moved to London and started working with Tableau, that was the time when LOD calculations were just released. And that was the big news, and everybody was talking about them. And you can imagine that as a new person, like product consultant within Tableau, I was a little bit confused what they do. But once I learned them, I started using them for everything. And then I realized the trend. So people who started working with Tableau or using Tableau before LODs were really confident and comfortable using table calculations. So they would solve everything with a table calculation because they knew all the hacks. Whereas people who started using Tableau after LOD calculations were released would stick to LOD calculations for everything. Well, this session is about learning why you should use both and when to use them. So I want to explore with you some examples where we will see when it makes sense to use a table calculation and when it makes sense to use an LOD. And why do we have this session? Well, because as you know, in Tableau, there are many ways to get to the same number, to solve the same use case using different methods. But not every method is the best. And as a good consultant, my favorite answer to the question, which is the best method, is, well, it depends. So it depends on the use case. It depends on what you're exactly visualizing and what you're aiming. And with this session, hopefully, we will explore what are the questions that we need to ask ourselves before making any choice of what type of calculation to use. So when you make a calculation type, you basically end up with a trade-off. It's a trade-off between the simplicity of the calculation, so how easy you write it, its flexibility, so how you can use it for advancing the calculation or the analysis further on, and how performant the calculation will be, or how expensive it will be on the database or on Tableau, your machine itself. The goal of this session is to learn what is the proper method to choose from the calculation types so that we can actually have more efficiency when we write the calculations. So it will save you a lot of time if you just know what calculation to start with. Second, it will increase the collaboration within the team, because if you select the proper calculation types, then people who work on the dashboards that you have created will be able to expand the analysis using, let's say, web authoring or self-service analytics. And finally, it will increase the adoption of any analysis that you do, because the dashboards that you create and the analysis that you do will be in their optimum performance. So For today, the agenda is very simple. We'll go through some basics, although this session is designed as an advanced session, and we will not dive deep into what table calculations are, how they work, or LOD calculations themselves. I would like still to go over some of the basics so that everybody in the room, even if you haven't used table calculations or LOD, know a little bit about them so that you can understand the concepts. So let's start with some basics. In Tableau, when we open Tableau, we see a visualization. It's a simple interface with drag and drop and create immediately a nice visualization. But actually, a lot is happening behind the scenes. So we need to understand what's going on behind the scenes so that we can understand what Tableau is giving us as a result. And the things that we really do need to take into consideration are the records of the data set, so what each row in our data represents, the order of operations that Tableau is using to do the calculations. Then we need to understand where the calculation is actually executed. And finally, what is the scope of the view? So what is exactly that we are seeing as results on the screen? So let's start with the records of the data. This is a very simple data set, which is about a survey with 4 participants. Because every record is actually a unique participant with a unique survey, the average that we see on the screen is the average score of satisfaction rate by participant. Well, it becomes a little bit different within this data set. It's actually the same data set, but we'll look at it, let's say, 3 months later. And we realize that the score has dropped. The reason for that is that one person has actually filled in the survey 3 times. So this score is no longer the average score per participant, because not every row is a unique participant. It's an average score, maybe by number of surveys filled in. So we need to understand what our records are in the data set that we're using so that we understand what the values we see on Tableau represent. Once we understand that, we also need to check what the order of operations in Tableau is. This is a screenshot from our website. And actually, if you Google order of operations Tableau, you will find a lot of pictures and variations of this process. And what it shows us is in what order everything will be executed to get to the number that we are seeing on the screen, so that you can understand where exactly the calculation happens and what it takes into account as data. The third thing is the execution of the calculation. So the execution of the calculation can happen actually in 2 places. It can be either in the database or it can be in Tableau. So understanding where the calculation happens is important, again, to understand what data is considered to get to the result. And finally, scope of the view, or some people call it the level of detail of the visualization. So the scope of the view is what we would say how the results are broken down by the dimensions that we have used. In the example that you see on the screen, we have category, subcategory, as well as segment on the screen, dragged and dropped in different shelves on the interface. And as you can see, every result is a combination of these 3 dimensions. So if we look at a single mark, a single result, this blue stack bar, we see that this is representing office supplies category, the binder subcategory, and the consumer segment. So the scope of the view is all of these 3. And all the calculations that we do, or some of them actually, we'll see later, will take into account that scope. So the scope of the view is determined by the dimensions that we drag and drop on the view, but not every shelf is changing the scope of the view. So the shelves that you see, which are highlighted, like columns, rows, mark card, like color, size, etc., will change the scope of the view, whereas the shelves like pages, filter, tooltip, they will not change the scope of the view. They will change the result because you're filtering, but they will not change the scope. Just to repeat, the 4 things that we need to take into consideration when we do any analysis with Tableau are the records of the data set that we are using, the order of operations, where the actual calculation is being executed, as well as what is the scope of the view at that point of time. So let's go now to some basics related to calculation types. In Tableau, we have 3 types of calculations: the basic expressions, the table calculations, as well as level of detail expressions. So this session is about table calculations and level of detail expressions only, but basic expressions is also one of the mix in this pot. So if you think of these calculations as a way to go from point A to point B, you can think that these are different types of transportation to take you there. They have different properties, let's say. Often they will get you to the same point that you want, or maybe close to what you want, and they will depend on different way of operating. So basic expressions can be something like a public transport in a large city. Table calculations could be considered to be like bicycle, whereas level of detail expressions are cars, personal cars. So let's start with basic expressions and why they are like public transportation. Well, basic expressions will use every record in the data. So they happen in the data source itself. But they will depend heavily on the scope of the view. So when you write a basic expression, the scope of the view will determine the results of the calculation. So that's why they're a little bit like a public transportation. You can go anywhere in the city, but there are defined stops that you need to get to. So you can't be in between a stop. So the scope of the view will be your stops that you can get to with these calculations. The second type are the table calculations. Table calculations are calculations that are executed within Tableau. So they depend on what is on the view, so what numbers or values we have on the view, and they will take into account only those values. They don't go back to the database to check for or extract other values. And because of that, filters that are applied on the view will be very important, because any filter will change the values that you see on the screen. And that's why probably they are a little bit like cycling. They are very flexible, but you need to use your own power, so the power of Tableau. And you may not go maybe everywhere in the city, because they will not be able to have the power to get you there. And finally, we have level of detail expressions. They, as basic expressions, happen in the data source itself, so they are very powerful. And they are more flexible than basic expressions, because they don't depend necessarily on the scope of the view. They can be on any other level of detail. So that's why they're a little bit like cars. They're more flexible than public transportation. They can't go everywhere like table calculations. So at some places, cars are not allowed. But they will be powerful enough to get you to almost anywhere in the city that you want. And just a reminder of how LODs are written, or what the syntax of LODs is. We basically have 3 keywords that we can use for LOD expressions: fixed, include, and exclude. And I would encourage you, if you would like to learn more about how to use and when to use them, to go to a session which is specific for LODs, and I will mention it in the end of this session. And then we define on what level we want this calculation to happen. And this gives us the flexibility that we want, because we can define the level of detail ourselves. And finally, we define what exactly is going to be calculated. In this case, we want to see the sum of sales by each customer. So let's go and do a little bit of Tableau with the knowledge that we have now, and see how this works in practice. For the examples that I will show, I'm using data from the FAA. which is actually real data. You can download this data from their website, and it's about claims submitted by passengers about things like broken luggage, lost luggage, or personal injury when they were flying with an airline. Every record of the data represents a specific claim, and as we said, this is the first thing that we need to know about the data, and that's why I would like you to see how the data looks like, what it contains, and so that we can understand what the results of our calculations are. So now we will use this data to explore when to use table calculations and when to use LODs. The first example that I want to show is about the simplicity of the calculation. So when table calculations are simpler than LODs, and when LODs become simpler than table calculations. On the screen, we are looking at the number of claims submitted to each airline. These numbers are showing us the total number. So Delta Airlines had, in this period of time, it's about 10 years of data, 25,000 claims submitted for, again, lost luggage, personal injury, etc. Obviously, these claim numbers are related, also correlated to the number of flights that these airlines do, so they don't actually represent anything specific for the airline itself. And we're looking at the top 15 airlines that fly to US. They are not only domestic, but also international airlines. What we want to calculate is, instead of looking at the total number, we want to see the average claims submitted to an airline on a yearly basis. So what is the average claims per year? The first option is to use table calculation. So let's see how this analysis can be done with table calculation. So I'll just create a new calculation here and call it average claims, TC for table calculation. And then the calculation will look like something like this. We want to take the average of these total number of claims per year. So one of the calculations that is really powerful is window. That's a type of table calculation. And if you want to see all other types of table calculations that are existing in Tableau, you can basically look at this grouping of calculations and select table calculations. So under table calculations, you will see all the functions that will give you, as a result, a table calculation. And these are things like first, index, last, so the sequence of any row or column, ranking, running totals, as well as window calculations, which will give you any aggregation that you want for that specific window that you define. So in this case, we want to use window average, because we want to look at the average number per year. And what we are looking at is the number of claims. So the calculation will look something like this. I hope that it's visible from the back as well. Window average, some number of claims. So if I drag and drop this onto the view, you will see that Tableau is giving me the same number for each airline, 9,800. And this number actually shows me the average number of claims for all the airlines that we see on the view. So Tableau immediately took the numbers that we see on the screen and took the average of those numbers. But the question is, what is the number of claims per year for each airline? But because table calculations work on the numbers on the view, I cannot calculate that number without introducing also the year dimension on my view, on my vis. So I'll just drag and drop the incident date here, and it will become like a larger table that you can see here. So let me just make it standard. So now you can see that the calculation happened on a yearly level, because the results are repeated for each year. So for 2002, for example, we had on average 69 claims submitted. Whereas we want the calculation to happen not on a yearly level, but per airline. So Tableau will always get a guess and will try to give you a result, but not always the result will be in the order that you want. But solving or editing table calculations is really easy. You can just click on the measure itself and edit the table calculation. And it will give you this really useful highlighting so that you can see exactly what Tableau is considering when it is doing the table calculation. In this case, the average is being calculated for each year separately. And the compute using is table down. So the only thing that I need to do is change it to table across, and all of a sudden the calculation will happen now on an airline level, and I can see the average claims per year for Delta Airlines is 1,797. And for American Airlines, it's 1,670. That's it. Well, the calculation is done. I got to the number that I wanted to have. But I have one issue, and that issue is the fact that now this calculation is repeated many times, as many years as I have on my data. What if I just want it to be seen on the screen only once? To do that, we can actually use another table calculation, which is index. Index will give me the order of each column on the view. So if I just type index like this, it will immediately show me that this is column 1, column 2, column 3, etc. I can use this calculation as a filter and tell Tableau, just keep the index when it's equal to 1. So if I drag and drop index to my filter shelf, I can just keep that number. And because it's a table calculation, it will just hide the other numbers. It doesn't really filter the results. It just hides them. So I can get to this number and the view that I want with a little bit of a hack. So let's see how it looks like if you want to calculate this with an LOD. For an LOD, I will create a new calculation, and I'll just say average claim LOD. With an LOD, I need to define on what level I want the calculation to happen. So I want to take the average per airline for each year that we have in the data. So I will use a calculation as fixed. And what I want to first know is how many claims I had for Delta Airlines, let's say, as it is in the top, for every year in the data that I have, so that I can first calculate the total amount per year and then take the average of these totals. So the first thing that I need to consider is the airline name. Because I have many airlines, I need to do the calculation for each airline separately. But also, we need to do the calculation for each year as well. So I'll just type year, incident date, and it will take the year of that incident date and will calculate it, the total amount for each year and for each airline. And finally, the thing that we want to calculate is the sum of our number of claims. So fixed, airline name, and year incident date. I need to use 2 dimensions in my dimensionality of the LOD calculation. So now if I just drag and drop that on the view, and then take the average of that calculation, because we are looking at the average itself, I will get to exactly to the same number that I got with the table calculation, which was 1,797 for Delta Airlines. And because this calculation happened in the database, and I didn't have to introduce the year on the view, as you can see, immediately I have one result per airline. I didn't have to use any hack. So let's look at another example about this, which will show us when a table calculation could be simpler than LOD. In this case, we are looking at the total number of claims per year as a trend line. And I can see the average of those years is 11,000. So we had a peak of claims around 2004 and 2005. And then there was like a steep increase in the number of claims. So now what I want to do is to calculate the so-called residual, or the difference between the actual number in each year and the average for the total period. So let's do that first with the table calculation. And I'll call this average difference, TC. The calculation itself will be exactly the same. So if you look at what we have on the screen already, we have the numbers of claims displayed. What I'm missing is the average of these numbers. And if you remember from the first example, that was a really easy calculation of window average and looking at the sum of number of claims. So it's exactly the same calculation that we used with example number 1. If you want to test your calculations, what they give you as result, there is a really cool trick to just highlight the part of the calculation that you want to test, and then drag and drop it on the shelf. And you will see exactly what this calculation does. And if I just show you the labels, you will see that this calculation gives me the average that we see here repeated for every year. And that's really handy, because what I can do now is take the difference between the actual number for the year and the difference. So what I need to do is just add here the number of claims, and then take the difference. When I drag and drop this view, I can now see the difference between that year and the average. And if we want to make it like a really nice chart, we can do something like this. Maybe combine these two charts and synchronize it and visualize everything in one view. So now let's see how this can be calculated, exactly the same thing with an LOD. OK. What we want to do is first, again, calculate the average number for the period that we are looking at. One of the LOD functions is exclude. Because the scope of this view is yearly level, but I just want to ignore that year is there and calculate the average, I can use exclude and say exclude year and give me the average. So let's do that. Exclude year of incident date and give me the average. Again, let's see what this calculation does, and I'll just drag and drop, highlight and drag and drop, and see the result. So as you can see, the result of this calculation is not actually what I expect, and it's only 1. Because if you think about the data and how it is structured, once I exclude year and take the average, what Tableau is going to do is go to the field called number of claims, which is 1 for each claim, and take the average. But because it's 1 for each claim, basically the average of 1 is 1. So what we actually need to do is, before we exclude the year, we need to tell Tableau, calculate the total for each year, store those values in a LOD calculation, and then exclude the year. So it becomes a little bit complicated. It's like a nested LOD calculation. So before we exclude, I'll just do it on a new line. We actually need to fix the calculation on a yearly level and calculate the sum. So what this calculation will give us, this part of the calculation, is the numbers that you already see on the screen. So this part of the calculation is storing those yearly values. Now I can take these numbers and take the average of those numbers by excluding the year itself. And now if I look at what this calculation does, should be giving me the year. Exclude year fixed. Let me see. Something is wrong with the calculation. Let's see what it does actually. So fixed the numbers to the yearly level, and now we want to exclude that number. Let's see. Exclude here. I'll just click OK, and drag and drop it again. Oh. As you can see, it gets really complicated when you use an LOD. And you can get lost in your own calculation that you have done hundreds of times. But the idea of this calculation is that once you create an LOD calculation with an exclude, you actually can't just write a simple exclude calculation and take the difference, because once you try to take the difference between claim numbers and the exclude calculation that you have created, Tableau will give an error message. And it will tell you you cannot mix a level of detail expression with an aggregation, because the level of detail expression itself is happening on a row level. So what you need to do is understand that concept and put something like a minimum or attribute or maximum in front of the LOD itself to aggregate the LOD to the level of the number of claims. So I'll just make this calculation a bit bigger. And the expression will look something like this. Although it doesn't give the exact result that I want, it will be as long as complicated as that you see on the screen. And then you need to drag and drop it again, because the aggregation of the calculation changed, and you now can look at the difference. Which is interesting, because the result of the calculation is correct. So if you, so if you look at what we see on the screen, is actually what we calculated with the table calculation. Magic. So OK, so the idea of these examples is to show you that sometimes table calculations will be simpler, and sometimes LOD calculations will be simpler. But what makes them different from each other? If you look, and the concept is really, really easy, actually. So if you look at the first example, what we needed to do to calculate what we want is to bring extra data to the view. Not everything that we needed was already there to do the calculation to take the average on a yearly level. Whereas on the second example, we already had everything that we needed on the view. So you had the yearly claim numbers, and you could use the yearly claim numbers to calculate the average and then take the difference between the two. And the first thing that I want to share with you as a takeaway about simplicity of the calculation is that table calculations will be simpler than LOD calculations when you already have everything, all the information that you need to do the analysis on the view. So they will be much, much simpler than writing a complex LOD calculation. But LOD expressions will be much simpler than table calculations if you need to go back to the data and extract more information from the data itself. Because taking that information using a table calculation requires you to drag and drop new dimensions and then change the calculation to take into account the dimensionality or the scope, the new scope that you introduce on the view. So let's build a framework for our understanding which calculation we need to use. The first question that we need to ask ourselves before we start writing any calculation is, do we already have all the numbers that we need to do the calculation on the view itself? If the answer is yes, then a table calculation is the way to go. Whereas if the answer is no, then an LOD will be the preferred option. Let's go to the next question. We now know how to write a simple calculation and when to use the calculation type that will make it simple for that use case. But what about flexibility? So is every calculation, although it's simple, flexible enough for the analysis that we want? Let's see it with an example about proportions. What we see on the view is, again, the number of claims by airlines. But this time, these values are broken down by the status of that claim. So what is the outcome of the claim? Was it approved in full? Was it denied? Was it settled? Or whether it's unknown yet? And what we want to know is what is the percent of claims that each airline denies so that we don't use that airline, maybe. So, or you don't have a choice sometimes. So let's try to calculate this number. Do we have everything that we need on the view to calculate percentages, percent of totals? Yes, because we already have the total value, which is the full bar, and we have every value broken down by the outcome of that claim. I can use a simple table calculation to get to the result that I want. And that table calculation actually doesn't require writing it, because some of the table calculations are already pre-programmed, and the way to find them is just to click on the measure itself that we want to calculate and go to quick table calculations. So for things like running total, percent difference, percent of total, year-to-date growth, etc., you can use this instead of writing the calculation itself. Tableau will write the calculation for you, and you can save it or amend it if you want to. So in this case, I want to use percent of total, and I'll just select it. Immediately, my axis becomes percentages, and if I hover over, I will see some small percentages. And you can guess what happened. Basically, Tableau took all the data, like not the claims per airline, but total claims to calculate the percent of total. And you know that we need to just adjust it, amend the calculation. Again, highlight shows us that everything was taken. And I'll just this time change it to, again, table across. And immediately, all of our results will go to 100% total, as we expect. Now I can see that Delta Airlines denies 51% of the claims. American Airlines denies similar percentage, but America West, for example, denies 35%. The next thing that I want to do is, everything is fine with this calculation. It did exactly what we want. But then I have a next question now. Can I sort these airlines based on the number of percent of denied claims, so that I can see which are the worst, which are the best in approving claims? To do that, you may think of just filtering for denied claims. And once you do, everything goes to 100%. And you probably now can guess why this is the case, because table calculations work only on the numbers on the screen. Once you apply a filter, you lose the detail, and then it basically checks each airline with itself, and it's 100%. So this was a really, really simple way of calculating percent of total. It was just clicking without even writing a calculation. But now if I want to expand the analysis itself and go one step further, I have basically a showstopper. Although in this case, LOD calculations will be a little bit more complex because you need actually to write the calculation, you will see why they can be useful in some cases, although the simplicity may not be there. So let's try to calculate the proportion using an LOD. To calculate the proportion, we need a nominator and a denominator. And our nominator is just the number of claims that we see on the screen. And why is it only number of claims? Well, because the scope of the view is already on the outcome and the airline level. So if I just write number of claims in the calculation, it will give me the results based on airline and outcome. So I don't have to do anything there. For the denominator, I need to write an LOD calculation. As we discussed, LOD calculations can be independent from the scope of the view, so I can write them on any level that I want. And what I want the denominator to be is the total number of claims per airline. And as if you just tell yourself in simple English what you want to calculate, it will give you already the syntax that you need to use. So I need to fix the total number of claims by airline. And my dimensionality, that's why in the LOD calculation will be airline name. And look at the total number of claims like this. So if I drag and drop this calculation, you'll see that it gives me exactly the same results as the table calculation. But the nice thing about this calculation is that once I filter, the results are still there. Because they happen in the database itself, Tableau still knows what these numbers are. Although we filter them in Tableau, it can go back to the database to check them. And I can now sort the airlines by their denied number of claims. So I travel with British Airways, not the best choice, but nothing happened to my luggage, so it's fine. So, okay. The next question about flexibility is that, are there situations where table calculations are much more flexible than LOD calculations? And actually there are. There are many use cases where table calculations will be much more flexible, and sometimes they will be the only choice. That's why they're like a bicycle. They can go anywhere in the vicinity of your vicinity, basically. They're not like cars which need to travel on the road. They can go like on the pedestrian, well, probably not legally, but they can go anywhere, more or less. So what we will do is we'll try to find out which are the worst offenders, or let's say the airlines which had the most claims by airport. Because most of the claims, we will not look at that part of the data, but if you analyze this data, most of the claims are related to either lost luggage or broken luggage, and that happens in the airport itself, often, I guess. So what we will do is look at the top 5 airlines in each airport. And to do that, I'll just drag and drop airline name like so. Let's just use a standard view so that you can see what's going on. So for JFK, the top 5 are JetBlue, Delta Airlines, American Airlines, etc. And how can I solve this with a table calculation? Well, it's really simple. What I will do, just so that you can see the result itself, is just copy the number of claims and do the calculation on this part. It's a table calculation that is also pre-programmed, and it's the rank. So one of these quick table calculations. So if I use a rank, it will show me the rank of the airlines based on the number of claims. I just need to make sure that this rank happens for each airline separately. So if you look at how the rank happened, it basically takes into account all the data. So the rank doesn't start from 1 for each airline. And the way to make it start from each airline is that each airline is actually a separate pane in the view. So there is a border between the 2 airlines. And I just need to change it from table down to pane down. So if I do that per pane down, compute using pane down, this calculation will start from 1 for each airport every time. Now I can use the calculation itself as a filter. So I'll just drag and drop this calculation and say, show me just the top 5 per airport. And you can see immediately the result. If you don't need the ranking, you can just take it out, but the result will be there. So again, no calculation needed, or at least not by just writing the syntax by yourself. And you can immediately get to the top 5 ranking. Well, when it comes to an LOD calculation, can you do a ranking with LOD? Yes, actually you can, but it's not a very preferred way to do that. I will not write the calculation itself because I don't want to make another mistake. But just a second, let me reopen it. It's getting more complicated than necessary, to be honest. And this calculation, what it does is just ranking the top airline per airport. So if I want to get to the 2nd rank, I need to write another calculation. And if I want the 3rd, I need to write yet another calculation. And you can see that it's not scaling. So if I have a certain number of ranking, like I want to see the top 5, maybe I can do it, like if I have time, just for the, for the fun of it. But if you want to take the ranking of each airline, then you can see that it goes to hundreds. You will not be probably able to practically write all these calculations. So that's why in those cases where you need recursive calculations, just a second, recursive calculations or moving averages, etc., you are much better off using a table calculation, and in many cases, it's the only way, actually. So when it comes to flexibility, table calculations or LOD calculations are very flexible if you need later on to apply a filter on a higher degree. Because table calculations will take that filter into account, but in many cases you don't want the filter to be applied on the calculation result itself, then LOD expressions will be more flexible than table calculations. Whereas table calculations become really flexible when you want to do recursive type of calculations. They can get you, with one calculation, you can get many results using just one table calculation, as you saw with the ranking. So you just apply it once, but it calculates it 100 times or as many times as you need in the data. And another use case where table calculations are more flexible than LOD calculations are when you need to work across data sources. So if you have 2 data sources that you need to refer to in a calculation, then a table calculation would actually be the way to go, because LOD calculations can work only in one data source. So you can't take a measure and a dimension when they are from different data sources. Now our framework is getting a little bit more complex. Before getting to the actual question whether we need to use all values or only some of them, basically there are 2 more questions that you may want to ask yourself. The first one is whether data blending is required. Because if data blending is required, you need to use a table calculation by default. And the second question is it a recursive calculation, like ranking, moving average, etc., or like lookups, like inter-row calculations? Then again, a table calculation will be the way to go. There is one use case where the only way to go, or the only option that you have, is actually an LOD calculation. And it's when you need to create a dimension. And the only LOD calculation that will take you there is fixed level of detail. So you can't use include or exclude or table calculation or basic expression. Actually, you need to use a fixed LOD. And the reason for that is because with a fixed level of detail calculation, you can basically create a result which is independent from the scope of the view. And because it's independent, it can be deterministic, and you can basically use it as a dimension itself. So the use case that we have here is we can see what we see on the screen is how many airports each airline flies to. So Delta Airlines has the most advanced network, at least in the data that we have. It may not be the case in real life, I don't know. So it's 297 airports that they had claims submitted about. And you can see all the ranking here. But what's interesting is that you have some airlines which fly only to 1 airport. And then there are some other airlines which fly to 2 airports, 3 airports, etc. So I want to know how many airlines fly to only 1 airport, how many airlines fly to 2 airports, etc. So basically, it's the reverse of this analysis. And because I need to create a dimension to break down the result by 1, 2, 3, etc., I can use a level of detail expression. I'll just write this number of airports, LOD, And that will be a simple calculation like for each airline, count how many airports they go to, they fly to. Like so. Because this calculation is, as I said, independent from the scope of the view, it will always give me the same result. Now, it's a measure because the answer is 1, 2, 3, etc. But what I can do is just drag and drop it to dimensions, and it all of a sudden will become a dimension. And now what I can do with this dimension is look at the numbers that we saw on the view on a reverse scale. So from 1 to as many airports an airline flies to. And now instead of looking at the number of airports, I can check how many airlines go to only one airport. And the answer is 32. And then 35 airlines fly only to 2 airports. And only one airline, which probably is Delta Airlines, flies to 299. So as you can see, with a fixed level of detail, you can create a dimension. And if your analysis requires that, then it will be the way to go. And that will include one more question to our framework, whether the analysis requires a new dimension. So in this case, you need to use an LOD expression. So before we move on, I would like just to talk about performance itself. Using LOD or table calculations will have different performance implications, and that's because of how they work. So with LOD expressions, because they are part of the underlying query to the data source, we basically depend on the speed of the data source that we are using. So all the calculations, all the analysis will be done by the data source itself. And if the performance is slow, then we either need to replace it with a table calculation or do the pre-calculation within the database itself. So because we will be bound by the speed of the database in this case. Whereas with table calculations, because we use only Tableau's power, so we are cycling basically, we need to understand how many calculations Tableau will do for that analysis. So in the case with the years and the airlines, we had, let's say, a combination of 15 airlines with 10 years, so 150 calculations. But imagine that you're trying to do a calculation on a customer level where you have 1 million customers. So a table calculation then would need to do 1 million times whatever other dimension calculation operations to get you the result. And the result may be just one number sometimes. So in the cases of table calculations, we need to be aware of what exactly we need to bring as data to the view to do the calculation itself. And if it's like too much of data, probably we're either doing something wrong or we need to go back again and do it in the database if level of detail expression is not possible. Maybe I can show you one example how it works with performance. And that is about looking, instead of number of claims per year, looking at number of claims per day. So as I said, when it comes to number of claims per year, we do 150 combinations or 150 operations. But now if we want to calculate it per daily level, we will need to multiply this 150 by 365. So it will be like a big number. And the reason why table calculations may not be the way to go in this case, even if they are simpler, is that just to do the calculation, I will first need to go to the level of detail that I want to do the calculation at. So I need to open each and every day in the data and do the calculation on this basically practically infinite table. So if you look at the marks number, it's 44,000. So I need to do 44,000 operations in Tableau just to calculate 15 numbers at the end. With an LOD calculation, as we saw, it will be a simple statement of saying what is the number of claims per day. Because incident date is on a daily level, I can just say for each day, calculate the number of claims. I just forgot that it should also be on an airline level. So for each day and each airline, calculate the number of claims. And then let's call it daily average. And when we drag and drop it and look at the average, we can see how many claims each airline got on a daily level. And it will give me only 30 results because all the calculations will happen in the database, whereas with this example, we have to do 44,000 calculations and then use something like an index just to get the 30 numbers that we want, because probably we don't want people to scroll to get to the next airline. So this is a consideration that you need to make as well, performance, because it will be a trade-off by itself. So to conclude, when we do decide between any calculation type, table calculation, LOD, or basic expression, we always do a trade-off between simplicity, flexibility, and performance. And you saw that sometimes simple calculations can be non-flexible, sometimes they may be non-performant, and sometimes flexible calculations may not be so simple, but they will give us the flexibility that we need. And because there are multiple ways of getting to the same number, we need to use something like the general framework that we just built together to answer first the questions that are important before even starting analyzing the data, because that will save us a lot of time. Just use the method to get to the point that you want, and it will be much more pleasant experience to get the analysis that you would like. And just, again, a simple reminder of the general framework that we built. It's really simple. We have just 3 outliers, probably, that we first need to consider. Is the recursive calculation? Does it require blending? Do we need to create a new dimension from the measures that we have? And if the answers are no to everything, we ask ourselves the general question of whether all the values that we need are already on the view. Then we use a table calculation. And if it's not the case, then we go and use an LOD. You may be able to find even more elaborate frameworks if you go to Google with many more questions. But I would like to keep it as simple as possible so that it's really easy to digest and to answer these questions on the fly with any analysis that you do. If you would like to learn more about table calculations or LODs, how they work, what are the use cases for this type of calculations, I would suggest you to go to one of these sessions. One of them is called Table Calculations for the Advanced Analyst, and it's a hands-on, and it will be tomorrow. And the other one is called Lots of Fun with Level of Detail Expressions or Calculations. And in that session, you will be able to start from scratch what an LOD is, what are fixed, include, exclude, when to use fixed, when to use include, when to use exclude, etc. And you can combine this knowledge with what we learned today to make sure that all the analysis that you do is fantastic, easy, and speedy. Probably you've heard it many, many times already, but please fill in the survey and give us feedback. We would like to improve these sessions as much as possible. Everything that you write in these evaluation forms is considered later on. And thank you very much for being here. Thank you. If you have any questions, I will be hanging around for the next 10, 15 minutes. Please come and we can discuss any question that you have. Thank you.